Hello, my name is Adrienne Wallace, and I'm a website development teacher for the East Baton Rouge Parish School District. And for this presentation in ELRC 7551, I will explore extended reality, commonly referred to as XR, and discuss how it supports immersive learning experiences that transform both teaching and learning in K-12 environment. Let's begin by defining extended reality. Extended reality is an umbrella term that encompasses all immersive technologies that blend the physical and the digital world. It includes virtual reality, augmented reality, and mixed reality. Each of these technologies varies in how much the real world is replaced or enhanced by digital content. Let's first take a look at virtual reality. Virtual reality fully immerses users in a computer-generated environment, often using headsets or goggles that block out the physical world. Next, augmented reality. Augmented reality overlays digital information, such as images, sounds, or text, on top of the real-world environment through devices like smartphones, tablets, or AR glasses. Lastly, we have mixed reality, which combines elements of both VR and AR, allowing real and virtual objects to interact in real time. Together, these technologies extend human perception by creating new ideas to visualize, simulate, and interact with information, hence the term extended reality. XR technologies provide unique affordances that traditional learning tools cannot. These affordances are 1. Immersion, full sensory engagement. 2. Presence, feeling part of the environment. 3. Manipulation, interact with digital objects. 4. Collaboration, share virtual spaces. 5. Personalization, adaptive XR environments can adjust to learner space, choices, and performance data, offering individualized experiences. Instructional benefits of XR. When used effectively in education, XR supports active, experiential, and constructivist learning. Students can learn by doing through simulation, role-playing, and scenario-based practice. Motivation and curiosity. The immersive and interactive nature of XR captures learners' attention and promotes sustained participation. Knowledge retention. Visualizing abstract or complex concepts in 3D makes learning more concrete and memorable. Empathy and perspective taking. Multi-user XR spaces enable learners to interact, problem solve, and build projects together in shared virtual settings. Safe simulation. XR prepares learners for 21st century careers by fostering digital literacy, spatial awareness, and problem solving in simulated professional context. Increased accessibility and equity. XR can provide virtual access to resources, environments, and experiences otherwise unavailable due to distance, cost, or other physical limitations. In summary, XR represents the next frontier in educational technology by merging physical and digital experiences to create immersive, interactive, and impactful learning environments. It aligns with modern pedagogical frameworks like experiential learning, universal design for learning, and constructivist approaches, making it a transformative tool for teaching and learning. Let's take a closer look at immersive learning. Immersive learning is an instructional approach that places learners in interactive, simulated, or experiential environments where they are actively engaged in the learning process. Instead of passively receiving information, such as reading or watching, learners experience the content firsthand through exploration, decision-making, and problem-solving within realistic contents. Immersive learning environments can be physical, digital, or a blend of both, but they always share a certain characteristic. 1. Active participation rather than observation. Contextual learning that mirrors real-world scenarios. Emotional and cognitive engagement through sensory interaction, such as visual, auditory, and kinesthetic. Authentic feedback loops that allow learners to test, fail, and improve in a safe space. This approach draws heavily on experiential learning theory and constructivist pedagogy, which emphasizes learning through doing, reflecting, and applying knowledge in meaningful ways. XR technology has leveraged immersive learning. Extended reality, which includes virtual reality, augmented reality, and mixed reality, has revolutionized immersive learning by providing technological means to fully simulate or augment real-world experiences in education. Here's how XR enhances and expands the possibilities of immersive learning. 1. Create realistic and safe learning environment. 2. Promote active experiential learning. 3. Enhance visualization of abstract concepts. 4. Encourage collaboration in virtual spaces. 5. Support personalized and adaptive learning. And 6. Boosting engagement and motivation through gamification. In summary, summary, immersive learning transforms education from moving beyond telling to experiencing and doing. XR technologies amplify this transformation by providing interactive, sensory-rich, and authentic learning environments where students can explore, experiment, and apply knowledge. Through XR, immersive learning becomes more accessible, scalable, and impactful, bridging the gap between theoretical knowledge and practical application. For this segment, I will highlight A-Frame, which is an open-source framework developed by Mozilla for building web-based virtual reality experiences. Unlike traditional VR experiences that require specialized software or headsets, A-Frame enables developers and students to create immersive 3D environments directly in a web browser using familiar HTML and JavaScript. This makes a perfect example of how extended reality is merging with web development and design education. It supports desktop, mobile browsers, and AR/VR headsets. Let's look at how a simple A-Frame project works. Step 1. Add an A-Frame library to a standard HTML file. Step 2. Create a scene. Define 3D objects using tags like a box and a sphere. 3. View and interact. Open the browser and explore in 3D or VR. And there you have it. Instructional benefits of A-Frame. A-Frame strengthens computational thinking and spatial reasoning while extending web development into immersive, experiential design. It encourages creativity, problem solving, and collaboration through interactive projects, offering a free open-source entry point into XR development. The platform aligns with EASD standards for educators, designer, and facilitator, and the Future Ready Schools curriculum, instruction, and assessment gear. In conclusion, A-Frame demonstrates how extended reality can evolve traditional web development instruction by enabling students to build VR and AR experiences with HTML and JavaScript. It connects core web design skills to emerging immersive technologies. Through A-Frame, learners move from simply coding on a screen to creating three-dimensional web environments, preparing them for the future of interactive digital design and web XR innovation. Thank you.